Okay, welcome to guide sheet number 1 on vector representation. We're going to deal with how we show vectors in multiple dimensions, specifically 2 dimensions. Again, vector quantities are ones that need to have both a magnitude, a size, and a direction. Our 4 most common vector quantities right now are displacement, velocity, acceleration, and force. If we're going to deal with those in multiple dimensions, we have to figure out some way to track them in 2 dimensions. Now, to be consistent, we're going to use degrees for our measurements as opposed to radians, and we're going to stick to a counterclockwise notation. Now, that means that we're going to use to the east, to the right as 0, straight up is 90, to the left is 180 degrees, and south or down is 270 degrees. Any angle that we measure, we will sweep and measure counterclockwise from 0. Now, the devices we'll be using to measure are protractors, and depending on the type of protractor you have, most likely it will only have 180 degrees, half of a circle. So if you measure something down in the 2 lower quadrants 3 or 4, you're going to have to flip the protractor upside down. Now, keep in mind, whatever you measure that way, you're then going to have to add 180 to it. There are circular protractors. If you'd like to get one, you can get yourself one and use that, and that would be great. Okay, so measuring the angles of a vector. Here's my vector. Now, my protractor is too large to measure this vector right now, so the first thing I'm going to do is extend it by drawing a straight line that I can then measure with the protractor. Now, when I'm using the protractor, I'm going to want to put the center of the protractor on the crosshairs here, right here where the x and y axis meet. Now, for my protractor, I've got a little circle which goes right at that spot. Okay, so I place that circle, that's my center, I place that right over the center of the crosshairs. Now, the other thing to be careful about is you don't want the protractor off at an angle from your x or y axis. You want it to be parallel to your x and y axis, so make sure it's lined up and that these lines are covering each other. Okay. Now all I have to do is, again, this over here is going to be 0 degrees. Now I do have 2 scales on this protractor. Since I'm going left counterclockwise, I'm going to use this inside scale. And it's a 26 and 26 and a half, roughly 26 degrees. So I'm going to call it 26 degrees. With 1 degree is about as accurate as I'm going to be able to measure that. And again, that is from 0, so that's counterclockwise. We'll talk about the magnitudes in a minute. Okay, for this one, I'm going to do the same thing that I was just doing. I'm going to extend the line because my protractor is too large to measure it as it is. I'm going to center it up. Yeah. I'm going to go around counterclockwise from 0. So again, over here is 0. I'm going to go around on the inside scale until I get to here. And then I'm just going to look closely and try to read that value. This is 100. This is 108. Okay. Now, we're going to try the next one down. Now this one is in quadrant number 4. This is the 4th quadrant over here. So I'm going to have to flip the protractor over. Now again, because I'm flipping the protractor over, I am going to be adding 180 degrees when I'm done. So my protractor is going to be upside down. I'm going to get it centered up on the crosshairs, get it lined up. Then I'm going to read around on the interior scale again until I get over here. I'm going to take a look and see what that value is. this is 150. This is 160. I'm two notches short of 160, so that's 158. Now, my answer is not 158. I have to add to that the fact that I did not measure this 180 degrees here. So 158 plus 180 degrees would be 338 degrees. Okay, this next one is in the third quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Again, I'm going to extend it out so I can use my current protractor. And then I'm going to flip the protractor over, line it up, and I'm going to look for, I'm going to read counterclockwise around. Alright, and this is 60, this is 70. I'm about 2 notches short of 70, so that's going to be 68. But again, I left off this 180 degrees, so I have to add to that 180 degrees. Alright, and that's 248. Alright, so 248 degrees around from here's 0. 180 plus 68 makes 248 degrees all the way around. Alright, now that's direction. The degrees tell you the direction. We also want to be able to tell the magnitude. Magnitude is shown by the length of the vector. Now, down at the bottom of the page, they tell us that we're going to use a scale of 1 centimeter equals 10 meters per second. So we're going to turn these into velocity vectors. They're not going to tell us which way, they're not going to tell us how far we're going, but how fast we're going. I'm going to use something with centimeters on it, in this case just a centimeter ruler. And I'm going to use that to measure the length of each vector and then convert it with the scale. Alright, so Alright, so this is in centimeters. This is 2 centimeters. I'm a little bit further than that, about 2 notches further than that, so that's 2.2 centimeters. I have to multiply it by the scale of 10 meters per second per centimeter. 10 is an easy number to work with. That'll be 22 meters per second. So our magnitude is 22 meters per second. Therefore, if I was going to write this vector down, I would say the velocity is equal to, and it is a vector, so I might put an arrow over the top to show it's a vector, 22 meters per second at 26 degrees. Again, a vector has to have both magnitude and direction. Can't have just one or the other. Alright, let's try the others. Hopefully you can pause it and actually measure these for yourself and get similar to what I'm getting. Yeah, so this one put down, it's just about 2.1, 1 notch beyond 2. So again, 2.1 centimeters multiplied by 10 centimeters, meters per second for every centimeter, and I'll get 21. So 21 meters per second. So this vector is equal to 21 meters per second at 108 degrees. The magnitude for this one looks like about 1.5 centimeters. I'm going to multiply that by 10. That's 15 meters per second. I'm only multiplying by 10 because that's the scale I'm using on this particular paper. You can come up with any scale that fits your page. Don't think that it always has to be 10. Alright, so that makes this velocity number 3 here, equal to 15 meters per second at 338 degrees. Okay, last one. Measure that length. So about 1.8 centimeters. I'm going to multiply that again by 10, and I get 18 meters per second. So the V4 is this fourth velocity would be 18 meters per second at 248 degrees. All right, so that's how you measure vectors. Again, we were measuring them as velocity vectors. They could have been displacements, they could have been accelerations, they could have been forces, they could be any kind of vector that we want. On the page, the paper, they're worth a certain number of centimeters, a certain length. But we can convert that into any length that we want. All right, that's it for this one. In the next one, we'll work with